applications of trig like we did yesterday. So we talked about when we have a right angle, we use right angle trig, our SOHCAHTOA. When we have two sides and an angle, we use our sine rule. When we have three sides and one angle, we use cosine. And when we're asked to find the area of a triangle formula, we have an angle and two included sides. We also looked at this example, but today we're focusing on bearings. So we have a ship sails for 200 kilometres on a bearing of 40 degrees. Then it sails on a bearing of 157 degrees for 345 kilometres. So we need to draw this as a bearing. We're going to sort of go to the left of our page, the right of our page, just a little bit across. And we're going to draw our compass or our axis about there. Okay, if I'm going on a bearing of 40 degrees from my north, I am here. Thanks, Noah. Okay, that is roughly where it is, and then I'm going to draw another bearing there. So let's put that information so far on. So we have our north. So far we have gone our 40 degrees. And then we have gone our 200 kilometres. Okay, this is where our ship starts from Sydney. All right, it gets to point A. We're going to call this point A up here. And it goes on a bearing of 157 degrees. So 157 degrees. And it goes for 345 kilometres. So it goes a fair distance. Maybe to there. All right, so we have our, we'll zoom in, 157 degrees and our 345 kilometres. And then what we're going to do is that is going to be point B. And we're then going to connect our triangle back up. Because our question for part A is asking us to find how far from Sydney is the ship to the nearest kilometre. So we are finding our distance x. All right, copy all of that down. Now, while you're copying that down, if you haven't got it already, what we want to do before we jump into the question is we want to start to find some information out and fill in our triangle. So what we have is, remember, whenever we have north-south lines, they are parallel to each other. And if we have a line cutting them, then we can create alternate angles. So what we have with this north-south line, and this line here, is we have alternate angles, okay? So that means that we will have that this angle in here is also worth 40 degrees. Now we have supplementary angles that add to 180 degrees. So that means this little bit in here is going to be 180 minus 157, which is, I'm just going to do a line off to it because it doesn't really fit, 23 degrees. So what that means is this entire angle here, okay, that is our angle SAB. Angle SAB is going to equal our 40 degrees plus our 23 degrees to get the total angle of 63 degrees. Okay. Now, what we're doing here is we're going to be looking in our triangle SAB. So, in triangle SAB, how many sides do we have, known or unknown? They can be known and unknown. 3. Okay, we have our 200, we have our 345, and we have our x. So, we have 3 sides. How many angles do we have? We have 3 sides, and we have, how many angles do we know? 1. We're all nervous. 1. Well, you can talk, but it's just not random stuff. You can answer questions and you can ask questions. All right, so if we have 3 sides and 1 angle, what rule are we going to use? Our cosine rule. So our cosine rule is c squared equals a squared plus b squared minus 2ab cos c. That's where we have our A, our B, our C, and then we have our angle C is in there. If you would like, you could draw a little tiny triangle down below that demonstrates that, but you don't have to because this one's pretty straightforward in terms of we can see all the information on it. Yesterday we had a lot going on, so it helped us to draw an extra triangle, but today we have enough information and it's easy to see, so we don't have to draw the triangle, but you can if you want. C, B, C. Okay, now what we just need to do is substitute into our cosine rule. So that means we will have x squared equals 200 squared plus 345 squared minus 2 lots of 200, lots of 345 cos 63 degrees. So we'll get x squared equals, now we've got to put 200 squared plus 345 squared minus 2 lots of 200 lots of 345 cos 63 into our calculator. And when we do that, we get 96,374.31104. Now that is a really long distance for x. Okay, so that gives us alarm bells, red flags. That's not our answer because that's our answer to x squared. We want to find our answer to x. How we get our answer to x is we square root that. So we square root our 374.31104. And when we do that, we get that x equals 310.442119. Okay, so x is 310 kilometres because it asked us for our nearest kilometre. Therefore, the ship is 310 kilometres from Sydney. Okay. Now, what our next question is asking, hopefully we've all got that copied down. Our next question is asking us, what is the bearing of the ship from Sydney to the nearest degree? So, what we have is, I'm going to just keep working on this diagram up here. You could draw another one down below. But what we have is we want the bearing of the ship from Sydney. So remember, we're going from Sydney. So Sydney is here. So what we are doing is we're finding the bearing from north down to that line of the ship. Okay, that is what we're trying to find for part B. So you can copy this down or you can not copy another one down. But if we're trying to find that bearing, how can we get that bearing? How can we find out what the angle from north all the way down to the line SB is? We need to find the angle inside our diagram. So we need to find this angle here. So that angle there we're going to call theta, and we need to find that because then it's going to be our bearing is theta plus 40 degrees. Okay, so if we just draw our triangle, so in triangle SAB, we want to find angle ASB, which we're going to let equal theta. And it has, so let's draw that triangle first. So when we draw that triangle, we have our theta here, we have 63 degrees here, we have our 310.44 dot, dot, dot. We have that this is 200 here, and we have that this is 345 there. Okay. There is two different ways that we're going to be able to find theta. We can either use sine rule or we can use cosine rule. Okay, because we have three sides and an angle, we could use cosine rule, or because we have two sides and two angles and we can draw across, we can use sine rule. So I'm going to use sine rule as we have two sides and two angles. Okay, so our sine rule that we're using is sine A over A equals sine B over B. So we will have sine theta over 345 equals sine 63 degrees over 310.44 dot, dot, dot. All right, so because we have a part B, we want to use the entire value from part A to help us with our rounding. Okay, so we never round until the end. This means that sine theta is going to equal 345 sine 63 degrees over our 310.44 dot, dot, dot. Okay, and that how we got that was by timesing both sides by 345. How we get theta is that theta equals inverse sine of 345 sine 63 degrees over our 310.44 dot, dot, dot. Put that into our calculator and we get that theta is 81 degrees 58 minutes and 7.22 seconds. Our question tells us to the nearest degree, so we can round that straight away to 82 degrees. Okay, to get our bearing, because the question was asking for our bearing is equal to our 40 degrees plus theta. So that is 40 degrees plus 82 degrees, which equals 122 degrees. So therefore, the bearing from Sydney to the ship is 122 degrees. To the ship is 122 degrees.